Hey everybody, in this video we are still on chapter 1 section 6 and we are on example 3 solving a work rate problem. One printer can do a job twice as fast as another. Working together, both printers can do the job in 2 hours. How long would it take each printer working alone to do the job? So we did this one in class already for this particular school year, and we talked about this, but um just something I've noticed is some people think like you're an artist just throwing, and even artists don't do this, but I think some people think artists do this where they just throw paint on the canvas and just splitter splatter and splishy splashy and boom, modern art, no, I doubt it. There's a method to the madness, okay? You need to write an equation. You can't just like add rates together and be like rate plus rate equals time. Like what planet is that a thing? You can't make stuff up. Okay? Like you actually have to use equations, like real equations. You know, like when little kids talk on the phone before they can talk and they just babble and they're like, blah, 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 blah. It's like, that's what some people's math looks like when you just like writing things down that you see in the word problem. It's like you don't know how to read. I know you know how to read, okay? So you need to read and you have to use equations. Like, I can't explain to you enough how silly you look when you're just adding random things together. Like, don't do that anymore, okay? Stop it. All right. So this over here, I keep equating to distance equals rate times time, okay? You have to know where the equal sign goes, right? Equal sign goes there, it kind of looks like the word dirt, and that's how I used to remember. But I know that not every one of these problems has anything to do with distance, right? This is more so like accomplishment equals rate times time, you know? So like you're accomplishing something, you're getting something done, and that is what equals. So accomplishment equals rate times time. It looks like it says account. Accomplishment. And let that be a valuable lesson too. Like the rate at which you're doing something and the amount of time you put into it, it's a direct variation. It's going to relate to what you are able to accomplish. What are you able to get done, right? So your accomplishment, maybe it's a distance that you ran, or maybe it's painting a house, or maybe it's, studying for a big test, right? So what are we accomplishing? A job. That's the accomplishment in this problem. What is this job? I don't know. We're making posters, we're making books, we're making something. So there you go. Now there's two printers that are able to do this, right? So we can kind of analyze them separately or we can analyze them together. And I do this in the copy room all the time. If no one else is there, I use both copy machines because I can get my work done much faster. I can get the copies made much quicker whenever that's possible. Okay, so I'm going to call it printer 1 and printer 2, right? Well, one thing I know is that one printer can do a job twice as fast as another. So if I let the rate here equal X, well, the rate here then will equal 2X. So which printer is faster? Printer 2 is faster. Its rate is double the other one. But keep in mind, if the rate is going to get bigger, the amount of time it takes will get smaller. I even equate that to, when you have like AC method and you have 24 and you're like, okay, it's 1 and 24. If I, looking at this way for a moment, double the 1, I get 2. Cut 24 in half, I get 12. Okay, well, what if I doubled the 2? If I doubled the 2, I get 4. So I have to cut 12 in half and I get 6. Don't all of these things multiply to give us 24? Can I double 4? Sure, that's 8. But then to keep it balanced, I have to cut 6 in half. That's 3. Does that also equal 24? So while this thing gets bigger, this thing gets smaller, right? That's basically what a direct variation will do. So they vary directly. That's what's going on. So as one rate goes up, the amount of time it takes for it to accomplish something, that will go down. All right. So that's all going to be very important. Working together, so simultaneously, both printers can do the job in 2 hours. Okay, so when they work together, they could do the job. So again, the job, that's one job, right? So that accomplishment is 1 equals the rate is going to be x plus 2x, both working together. And they can get the job done in 2 hours. So is everyone seeing that I'm not just making up an equation, like throwing paint at the canvas and hoping for the best, right? Okay, so that's what I got so far. So what am I looking at in this equation? Well, in this equation, I have one equation, kind of really solid set up for me, and I only have one variable in this equation, so that makes it quite easy to solve. So 1 equals x plus 2x is 3x times 2. So that means 1 equals 6x. So x is equal to 1, 6. Now, what does that mean? That means printer 1, the rate of printer 1 is it can get done 1/6 of the job per hour. You could also take that fraction 1/6. Think of it when we had long division and we had a fraction in the remainder, and I told you to pretend like you would push the 6 down into the denominator. So you could say 1 job every 6 hours. But usually we say per hour, so we leave that fraction up top for that description. So that one will do 1/6 of the job per hour. And then if you double, because the other printer is twice as fast, well, then that printer, printer 2, I guess we could say the rate is 2/6 of the jobs per hour, but we would probably reduce that, right? So this printer can do 1/3 of the job per hour. That's if they're working alone, right? That's how fast they work. That's their rate if they're working by themselves. So I use that first 2 sentences right there. How long would it take each printer working alone to do the job? Okay, well, you barely even have to do anything. So printer 1, do we say that's the faster or the slower? Let's note this so that, we see if it makes sense. I believe we said it was the slower. Do you remember? And if I really filled it into the equation, right? If I filled it in, accomplishment, let's call it accomplishment, equals rate times time. I want to accomplish one job. My rate is 1/6 of the job per hour times t. How do I get t alone? I'm going to multiply both sides by 6 to get rid of the 6. It's the reciprocal of 1/6 over there. So that's gone. And we get that t time equals 6 hours. So printer 1, the slower printer, it'll take 6 hours. Oops, sorry, I'm not even on the screen. How dare I? Printer 2, we said this should be our faster printer, and it should be twice as fast. So if our answer is right and it's twice as fast, does that mean it takes 12 hours? No, don't be silly. So it means it should take half as much time, right? So if I fill everything in, accomplishment will be one job. The rate is 1/3 of a job per hour. Time is what I'm solving for. How do I get t alone? I'm going to multiply both sides by the reciprocal of the coefficient of t, which is times 3 times 3. Those are gone. On the right here, I have t equals, and on the left, I have 3 hours. So yes, it took me less time because this printer is faster. So this one takes 6 hours. I guess I abbreviated in one and not the other. And the other one takes 3 hours, and that's it. So I would do it again. Think about it, let it soak in, and make sure you fully understand the problem, right? So final answer, printer 1, 6 hours, printer 2 is 3 hours. So what did X stand for? The rate of printer 1. Then printer 2 was 2 times that, so 2x. It is not a bad idea, like I said in class, write your let statement. We talked about that when we did word problems at the very beginning. And once you know what your x or whatever your variable stands for, then you're on to a good trajectory. So you want to make sure you really know what you're setting up to do, okay? But that's the example 3. That's the end of that. And we got some equations with radicals. So this is going to be fun. So buckle up. All right. Check the playlist in the description or the thumbnail on the end screen. And buckle up, please. Put on your math nerd hat or your I want to learn pants, and let's go, because these are important equations and these are a good time. Okay, see you later. Bye. Adios.